Hi everyone, welcome to my YouTube channel IT Made Easy by vinodsebastian.com. In today's topic, we will talk about regular expressions or regex. In the course video outline, we will go through 1. What is regex? 2. Notes to remember with examples from Python. And 3. Greedy versus reluctant versus possessive quantifiers. What is a regular expression? A regular expression or regex is a sequence of characters that forms a search pattern. Where do we use regular expression? A regular expression is used in 1. To find a search pattern inside a text. 2. To find and replace a search pattern with a replacement pattern inside a text. Or 3. To validate a text against a regular expression. Let's dive deep into the concepts of regex. For this purpose, I have opened the command prompt and started the Python 3 interpreter. I'm going to import the RE module, and let's take each example and play around with it. So the first concept is the dot matches exactly one character. One character is exactly matched. Then let's go through the next three concepts. Asterisk matches 0 or more times. Plus matches 1 or more times. Question mark matches 0 or once. Let's see these in action. So this should match 0 or more times. 0 times, 5 times, because in Python the search is greedy. You can see 1 or more match, 0 or 1 match. Now next set of concepts is square bracket matches any character inside the brackets. Square bracket with the hat matches every character except the one inside the bracket. Let's see that example. This matches every character H and L, and this will match every character except H and L. Backslash capital D represent non-digit character. Backslash small d represent digit character. This should represent the non-digit character, and this should represent the digit character. Slash W is same as the alphanumeric digit underscore regex set, and backslash capital W, everything except that. So this is true. This also, one second. Sorry. This is also true. You can see it again here. slash b is same as the regex shown here, and hence let's check it out. This has matched the word boundaries. Slash s matches white space, that's the smallest, and slash big S matches anything but the white space. This should match white space, and this should match everything except that. Now some extra concept that is regarding flags. Let's go into two flags for the time being. There are many other flags, but multi-line flag and ignoring case flag. In Python, they are written as RE multi-line and RE dot ignore case, and they are clubbed together using binary OR and passed as an argument. The generic regex syntax is as below, as highlighted. Let's see an example regarding that. You can see that hello and how are in 3 lines, and due to the multi-line flag, the matching happens across different lines of text, not a single line. Similarly, RE dot ignore case would have ignored the case of this string to be matched. Now let's go into 4 concepts. That is regarding the hat, regarding backslash capital A, regarding dollar, and regarding backslash capital Z. Now, token capital Z does what small z does in other engines. So backslash capital Z is in Python, what backslash capital small z is in other regex engines. So let's try the 4 examples and let's see what's the difference. Between this line and this line, you could see the matching is different. The caps lock H match to H. That is the H in different, starting in different lines. But backslash A match only the starting H in the text. That is because hat matches beginning of the line or string, and backslash A matches beginning of the string and not the beginning of the internal line. Similarly, dollar matches the end of the line or string, including the internal line, and backslash Z matches end of the string and not the internal line. So this line would match the internal end of the line and provide D, whereas this won't be matching with anything. Next concept is regarding pipe. Pipe separates alternate possibilities. For example, A pipe B means A or B. Let's see that. Here HE and HO are selected. Z5 means 5Z to match exactly 5Z. You can see in this example exactly 2 else gets matched. An extended concept of this is curly braces m and n denotes the minimum m and the maximum n match count. For example, in this case, this would match 3 to 4 else. Finally, the concept is regarding parenthesis. That is this. Now, let's see we write a set of elements inside the parenthesis. This is considered as a single group. And this gets captured as special characters labeled $1, $2 till $9. That is the first capturing of ABC in this case. If it is written inside Regex, it is stored in this variable $1. The next capturing will be stored in a variable $2 followed by $3, etc. These can then be used to replace the replacement string. That is, whatever we have captured in $1, $2, they can be now merged inside the replacement string. So, parenthesis groups a series of pattern elements to a single element. They can be used to match and remember the match. The matches discovered can be used in replacement text. Thanks, and let's move to the next session. Start. We are going to talk about 1. Greedy quantifiers, 2. Reluctant quantifiers, and 3. Possessive quantifiers. Greedy quantifiers. In Python and some other implementations like Java, the common quantifiers like star, plus, and question mark are greedy by default. It is called greedy because it tries to match as many characters as possible. And this can be done with backtracking also. In reluctant quantifiers, it tries to match as little as possible. So it is called reluctant or non-greedy. This also can backtrack. Possessive quantifiers like plus star, plus question mark, as seen in Java, does not allow backtracking. This is also greedy by nature. Another possessive matching example is for atomic grouping. Here again, backtracking is disabled, and the typical syntax is question mark greater than group in parentheses as shown or highlighted. Possessive quantifiers are easy to implement. So in short, greedy quantifiers allow backtracking, reluctant quantifiers allow backtracking, possessive quantifiers do not allow backtracking. Greedy and possessive quantifiers are greedy in nature, and reluctant quantifiers are non-greedy in nature. Let's see some examples. The first line dot star test is a greedy quantifier. This would try to match as much as is possible. That is, dot star would initially try to match the entire highlighted string and then follow it with test, which it fails. Then it tries to match till the highlighted portion as seen here and follows it by test, which again it can't match. Then it tries to match the dot star tries to match till TE, followed by test, which again it fails. Finally, one more time it tries to match till here, the dot star, and then follows it by test, which again it fails. Finally, the dot star matches till here, and followed by test, it finds the text. So this is an example of VD quantifier, and it will give the start index as 0 and ending index as 50. Now what happens for a reluctant quantifier? A reluctant quantifier will start with a minimum. That is, dot star will match here, then it will match here, then the test portion will match here, and you can see X test starting at index 0 and ending at index 5 is matched. Followed by, it tries to match X test, XX test, 3X text, 4X text, 5X text, like that till here it's matched. So it gives the index at 5 and ending at 15. Now, finally, for possessive quantifier, we know that backtracking is not existing. So it is greedy. So the dot star will go for the entire string, then it tries for test, which for which there is no match. Thanks for watching, and please do like, subscribe, and get notified.